The question is, a parallel plate capacitor is charged and then disconnected, right? Then disconnected from source of steady EMF. The plate are then drawn apart further. Again, it is connected to the same source. Then that means we are having 4 choices. Now we have to choose the best choices among these 4. So what it is said, initially a capacitor is charged. I may say like this, you know. So this is how the capacitor being charged initially, right? So this is the way how we are charging the capacitor. This is the potential of the battery. Say C is the capacitance of the capacitor. So during this moment, the charge that stores in the capacitor is Q. So there are several informations that should be given. A physical capacitor, you know, if this is written like this, the distance between the two plates, if it is D, and we are having air or vacuum inside, okay, so vacuum, then how actually we write this? If the plate area is A, so then C is equals epsilon O into A divided by D. So capacitance of the capacitor never depends on charge, okay, so it never depends on charge, otherwise it never depends on the current, whatever it is, or potential, okay, so it never depends on all these electrical parameters. So capacitance is a physical parameter, that is a quantity. So capacitance will be more if we have chosen bigger area of the metal plates used in the capacitors and less distance between the plates, that means the capacitance will be more. So now in this circumstance, what they are saying, soon this capacitor is released from this circuit that is disconnected, okay. So on disconnecting this capacitor, say we are having this one, this is the same capacitor of capacitance C and charge Q. The capacitor will be completely charged to the potential difference V, which is exactly equal to the terminal potential difference of this battery, say it is V. So now you know what we can write here is C is equals Q divided by V, okay. So this is how we have to interpret first. So next, what actually we are doing in this question, they are saying the capacitor on making disconnection from the source of the potential, the plates are moved apart, okay. So these two plates are moved apart. So D increase, right, so D increase. When D increase, I say the distance between these two plates now as D dash. So now you have to think about the situation right now. You must be careful, nothing happens to the charges because charge always conserve, okay. So on one side we are having plus Q and on other side we are having minus Q. Still that amount of charge remains on the same plates as it is. But now you have to think about the potential difference. So what happens to the potential difference? So now thinking about the potential difference, first of all I have to tell you about the electric field. Electric field between the plates of the capacitor, so the each plate of the capacitor will give the electric field, some constant electric field. Otherwise, as we know, at any point in between the plates of the capacitor, we are having this much electric field which is constant. So because the charges are as it is and the electric field in between the plates never depends on the physical parameters, okay, so this is a constant, okay, this is the constant. But now you have to think about the earlier situation, this one. So this V, how we can write this V? So you must know an equation, that is E is equals, right, it is minus dV by dx. This is the thing what we usually use, right. So from this notation we can simply make use something like this, what we can write, E is equals V by d, only the magnitude I am thinking about, V by d in this situation, right. So this E is constant, that means V is proportional to d, right. So this is the beginning situation, initial situation. And now what happened, since this E is constant, what I can write now, if the new potential difference between these two, say it's V dash, okay, the potential difference between the plates now is V dash. So V dash is proportional to the new distance between the plates, which is d dash, okay, so it is d dash. So now what happened, as distance increased, now we have to think about the potential, that is what I can write, V dash divided by V is equals d dash divided by d, right. So this one, and d dash is more than d, right. So d dash is more than d, so which implies what, V dash by V is greater than 1, otherwise I can say V dash is greater than V. So from this what I can conclude is, as the distance increase, right, as the distance increase, potential difference between the plates, potential difference between the plates increase, right. So potential difference between the plates increases. So having said all these things together, now we have to combine all the results to know much more things. Say Q dash is the charge, afterwards new charge, but you must know the charge always conserves, right. So that means the new charge and the original charge are same, the beginning charge are same. So now what I have to think is about C dash, which is the new capacitance, which is equals epsilon O into A divided by d dash. We did nothing to this area, right. So this area is constant, we are not altering the plates of the capacitor, the size of the capacitor plates, we are simply increasing the distance. Since the distance increased, capacitance decreases from this notation, right. So as distance increases, capacitance decrease, okay, capacitance decrease. So now what I can write is C dash is equals, right, Q dash divided by what, so divided by this V dash, which is new one, okay. So charge should remain as it is till the capacitor is isolated, okay. So it is isolated where the capacitance is C dash and potential difference is V dash. Keep that in mind. Till now I am not connected this capacitor to the battery again, okay. So now I am completing the question, that means again I am connecting this capacitor to the battery, okay. So this is the battery and now I am connecting the capacitor with a increased distance between the plates. Still, the battery is at the terminal potential difference V, capacitance is C dash, distance is D dash, and potential difference is V dash. You must know V dash is more than V. When we connect this one like this, okay, at these two terminals, the potential difference on this side is more and on upside is less. This should not happen. So then comes the equilibrium. Okay, so this will avoid now. So what happens? V dash decreases till reaches V. Okay, so till it reaches V. So to do this, capacitor should lose charge. Capacitor should lose charge, right? So capacitor should lose charge. That means the charges whatever here, which is Q dash is equals Q, the beginning charge is equals final charge, this will reduce. Okay, so the charges will flow, means, right? So means what I said, so charge should be reduced. To do this, that means to reduce the potential on the capacitor till it becomes equal to the potential difference of the battery, right? So to happen this, the capacitor should lose charge, extra charge. So that means charges now flow from capacitor into the battery, So this will result in this one. That means the potential difference across the terminals of the battery, I mean capacitor, decrease till it reaches the potential difference of the battery. Okay, so now the conclusion what you can see here in the question is option A says the potential difference across the plate increases. Yes, this happened as the distance between the plates increased, the potential difference across the plates increase, right? So this option is right. The charge from the capacitor flows into the source. Yes, I said the charges flow from capacitor to the battery. Okay, when the capacitor is reconnected, be careful when it is reconnected. Unless you reconnect it, the charge on the capacitor remains unaltered. So this also correct. Now option C, more charges is drawn to the capacitor from the source during the reconnection. No, this is not true, right? So this option is wrong. And D, the electric intensity between the plates increases. Electric intensity means E. Okay, between the plates increase during the drawing apart of plates. This is wrong. That means E remains unaltered, right? So only options A and B are correct, C and D are wrong.